In this video, we're gonna try something new and see if we can do this in under a minute for a short. This is for one a day 14, example 1, math 230. We're asking to find the curvature of the circle. The circle is given by the vector coordinates 3 cosine t, 3 sine t. The curvature is found by looking at the magnitude of the tangent vector, of the derivative of the tangent vector. And so these are various ways that you can consider or think about it. So for our vector, we're going to first find v of t, which is of course r prime of t, which we find component-wise as negative 3 sine t, 3 cosine t. The magnitude of v is taking the dot product and the square root. We're going to have 9 cosine. Oh, that was let's try that again. 9 cosine squared t plus 9 sine squared t. As you know, the sine and cosine squared, if I factor out the 9, equals 1. So this is the square root of 9, which is equal to 3. In other words, if I go like this right here is equal to 1 by the Pythagorean identity for trig functions. And so looking at t, finding the tangent vector first. This is the norm of v divided into the vector v, and so we have the norm of it, and so we have 1/3. We have negative 3 sine t, 3 cosine t. The 3 distributing that in gives us a sine t negative and a cosine t. All right, so there's our unit tangent vector, and then the derivative of t with respect to t is going to give us negative cosine t and negative sine t. And the magnitude of this dt is equal to, taking the dot product, this is going to be cosine squared plus sine squared. So this is actually just equal to 1. All right, now that we have all of the pieces necessary to compute the curvature, kappa is going to equal the norm of dt over dt times 1 over the norm of v of magnitude. So this is going to be 1 times 1/3, which is equal to 1/3. Most importantly, notice that this is a constant, which you should expect for a circle, since the circle is a fixed distance from a center point. So it makes sense that the curvature would be a constant. Also notice that for a circle, that kappa is equal to 1 over a if a is the radius of the circle. Okay, all right, that was helpful, and I'll see you in the next video. In example 2 here, for 1 a day 14, we're going to look for the curvature of the function natural log of cosine of x over the domain of negative pi over 2 to pi over 2. All right, so just like before, we have r is going to equal e and natural log of cosine of t. So we're going to use this as our parameterization, which then gives us, taking the derivative of r, that dr dt is going to give us the velocity, which is equal to 1, and let's see, take the derivative of this is going to be 1 over cosine. Take the derivative of cosine, you're going to have a negative sine. This is going to give me a negative tangent of t. And so there's our v, and then now let's look at the magnitude of v. So v is dotting this with itself, and taking the square root, we're going to have 1 plus tangent squared t, which you may recognize from the Pythagorean identity as secant squared t, and that is secant of t. All right. Let's see. And then t, we can now compute. That's v over the norm of v, which is, let's see, yeah, 1 and negative tangent of t. We're going to multiply that by 1 over secant, which would just be cosine of t. That's the 1 over this. So that means that we have, this is going to be cosine t and a minus sine t. Because cosine, tangent is sine over cosine. So the cosines will cancel, leaving us a sine. It looks like. There we go. And then, okay, now let's compute the derivative of our t. So dt, and that's going to give us a negative sine t and a negative cosine t. Okay, so there's dt. The magnitude of this dt is 1. And so our normal vector is going to equal negative sine t, negative cosine t. Just FYI, don't really need that. We're looking for kappa. And so I have 1 over v dt. Okay, so that's what we're using to find it. And so the magnitude is 1, and the magnitude of this is cosine. So we have cosine t times 1, which is cosine of t. And that is the result for a curvature. Hope that was helpful, and I'll see you in the next video. All right, in this last example 3 here, we're looking to find the tangent and the normal vector. So we're going to find those two for the circular motion given by this r of t. All right, so just like before, we're going to find b of t, which again is taking the derivative of this, and so we're going to get negative 2 cosine, 2 sine 2t and 2 cosine 2t. So there's our derivative, and the magnitude of this is going to be, dotting this, you're going to get 4 sine squared plus 4 cosine squared. Factoring out the 4, you're going to get the square root of 4 times 1, which is 2. All right, so our tangent vector is v divided by the norm of v. So we get 1/2 times negative 2 sine 2t and 2 cosine 2t. So the 2's cancel, and we're left with sine 2t. Sorry, negative sine 2t and cosine 2t. Okay, and now let's take the derivative of this vector so that we can find the normal vector. So dt is equal to, we have negative 2 cosine 2t, and then a negative 2 sine 2t. Okay, the magnitude of this one feels kind of like deja vu, if you will. It should be vectors. Is going to be this squared plus this squared. That's going to give me 2. This is going to be 4 cosine squared plus 4 sine squared. Factor out the 4. You're going to have 4 times 1. Square root of 4 gives us 2. Okay? All right. And so then the normal vector is just going to be dt times 1 over the norm of dt, which is going to give us 1/2. That's coming from here. And the derivative of that was negative 2 cosine 2t and negative 2 sine 2t. That's it in. And so our final result then is multiplying everything through. The normal vector is negative cosine 2t negative sine 2t. All right, I hope that was helpful, and I'll see you in the next video.